Hello, everyone, and welcome to another Applying Ethology webinar. I am Laura Whalen, and together with Jen-Yan Chow, Christian Nauroth, and Sebastian Glaman, we organize these webinars in the Animal Welfare Slack workspace. As we begin today, I want to remind you all to please turn off your camera and microphones. Should you have questions for our speaker, please type them into the chat box, and we will address them at the end of the presentation. It is my pleasure to introduce Stijn Brouwers from Agroscope. Today, Stijn will discuss cubicle housing systems for dairy cows and share how the hardware in this housing affects the movement of cows when standing up or lying down. Welcome, Stijn.
Yeah, thanks a lot for that introduction. I'm Stijn, and I just 1 month ago defended my PhD thesis on the subject of lying cubicle design and dairy cow rising and lying down behaviors. And I conducted that research in Switzerland for Agroscope and together with the Federal Food Safety and Veterinary Office, because they often have to check the housing systems for dairy cows in Switzerland. And they wanted to know more about the specific effect of the housing system on the ability of dairy cows to rise and lie down. So first, a little bit background about cubicle housing systems, or also known as freestalls in North America. They are open housing systems where cows can move freely throughout the barn. So they are not continuously tethered as they would be in tie stalls. And the stable is divided into different functional areas. So you have a part where the cows can feed, an area designated for lying, for drinking, and the cows can walk in between these areas in the walking alleys. Now, as you can see, the lying area is separated into individual lying places by these metal fences. But there sometimes can be a trade-off in cubicle housing between the comfort of the cow, especially during lying, and the hygiene of the animal. And now, why is that relevant? Dairy cows are very big animals, and especially during rising and lying down, they have to displace a lot of weight. And they also execute these movements according to species-specific and innate movement patterns, where first the cow will rise up her sternum and then really throw her head forwards to gain enough momentum to then first lift the hind legs. And then finally, she will also rise from the front legs. And this is a movement that she, when possible, always executes according to this movement sequence. And also when lying down, she has a really fixed behavioral sequence there, where she first lowers the head to inspect the lying area, because she wants to make sure that it's a suitable lying place for her and she can lie there for a while at least. And then she will perform the reverse movement pattern of the lying down. So first lowering her front legs, and then finally also lowering her back legs, and then she lets herself really fall onto either the left or the right flank. And now, especially during rising, during this head lunge movement, the cow stretches forward and she can be as long as 3 meters at that most stretch point, so to say. So she needs some additional space in order to rise up from the lying position. And let's come back then to the lying cubicle, because this is designed as you can see here, and it has multiple elements, one being the partition, that is this metal fence that separates each lying place from the next one. Then on top of the lying partitions, there's usually a transverse rail or flexible strap called the neck rail. And the lying area where the cow can lie, it's delineated by, in the front, a brisket board, which is a wooden or metal board usually, and in the back, a rear curb, also to keep the bedding inside this lying place. And all these elements or cubicle hardware, they are there to guide the cow into the cubicle, parallel to the partitions, and then the neck rail, it stops her from walking too far forwards, so that when she defecates, ideally it falls in the walking alley, which can be cleaned more easily by either automatic scrapers or by hand. And that the bedding material in which the cow lies, that it stays clean, also to reduce the chance of other infections. And in the front, the lying cubicle can face either another lying cubicle, so they will be head to head with another cow, or they can face a wall. And especially in the case when an lying cubicle faces the wall, the area that the cow has to lunge her head, it's defined by this space between the brisket board and the wall, which we call the lunge space. And the classic idea is that the more restrictive you position all these elements, so the less extra movement space there is for the cow, the more hygienic your cubicle is, but that cow comfort is quite low. And that when you move to a more permissive design, cow comfort increases, but again, the cubicle hygiene decreases. So the idea is that there is a trade-off between these two things. It would, of course, be good if we could find somewhere a middle ground between these two factors. There are a lot of variations in lying cubicle. For example, here you can see multiple different lying cubicle partitions. And these are just a couple of those that are around. There are really a lot of them around. And just to give you an idea, I would say that all these ones you can still find on farms today. And obviously, they can have very a different impact on the way that the cow can move the space in the cubicle. Of course, the dimensions of the lying cubicle can also vary. So the length of the bed can vary, the length of the lunge space, also the width of the cubicle. Then the neck rail, as I already said, it can either be a solid rail, but also a flexible strap. So it can differ in material, but also in the position where it's placed. So the height above the bedding, but also the distance towards the rear curb. And then the bedding, it can also differ. So you can have cubicles that are really bedded with a thick layer of straw. There are also cubicles that have a rubber mattress. This was not part of my PhD, so I won't focus anymore on bedding today in this presentation, but just know that this can also vary. And cows, they can have difficulty rising. That was what my PhD was about. This is a classic example when a cow does not have a lot of space. She first needs to rise from her front legs because she cannot really make this head lunge in front of her. And this is known as horse-like rising because it's the same to how horses would rise. And this is an abnormal behavior for the cow. It contradicts with her natural movement pattern and might be painful or it might be uncomfortable for the cow. This is an extreme example. There can also be other examples. I hope you can see the video well, where we can see a cow really needing multiple head lunge attempts before she finally manages to gain enough momentum to rise from the hind legs. And as you can see, at the point where she does make a successful head lunge, and she is resting on the carpal joint, she needs to take a step backwards because the neck strap in this case is still limiting her from rising with her back up. So this cow obviously has some issues with rising. And that can also affect the way that the cows lie down. Here you see a cow entering the cubicle. It is normal that she first inspects the bedding material a little bit. But in this case, you will see that she also starts to paw away the bedding, maybe a sign of frustration or at least not satisfied with the way the cubicle is. And she is also repeatedly trying to put weight on her front legs. And you could also see some repeated motion with the head while during the inspection phase. So these are maybe indicators that the cow is hesitant to lie down in this place. So far from the background, the objectives of my PhD thesis, we were interested to see whether these flexible neck straps are as effective as neck rails. And we also wanted to assess the effect of their positioning on dairy cow behavior in lying cubicles. So that was one study we did. And then in another study, we investigated the associations between cubicle design more generally and rising and lying down behaviors. But we did this specifically in barn buildings that have a really small lunge space for the cows. So then we come to the methods. First, the study on the neck strap positioning. So just to give you an idea, the neck strap, it's made of a nylon lashing strap material. And you can see it is a bit flexible. So when the cow hits it, there is not an abrupt cessation of movements, as there would be with a metal rail. And we were then interested in to see what the effect would be of positioning of this strap on cow behavior. So we conducted 2 experiments, one on the neck strap height, where we tested 105, 120, and 135 centimeters above the bedding surface. And then we also conducted a second experiment on the neck strap distance to the rear curb. And there we tested 170 and 155 centimeters. And the effect, and we did this in our research barn in Switzerland, where we have 2 pens of 20 cows each. But what I wanted to say is the neck strap, in order for it to be effective, it needs to be slightly below the wither height of the cow, otherwise she can walk underneath it. So we wanted to relate the positioning to cow body size. And as you can see here, we measured the wither height of the cows and also the diagonal body length. And then we analyzed neck strap height divided by wither height, so we could get the relative space for each cow. And we did the same for the neck strap distance to the curb. We divided that by the diagonal body length of each cow, so we also had a relative neck strap distance, basically. So now we have 2 continuous variables to analyze. Then we collect the data using accelerometers attached to the left hind leg of each cow. As you can see here, there were these triaxial accelerometers. Then using the Triact R package that a colleague of mine developed together with me, and it basically makes use of the fact that the leg of the cow changes orientation during standing and lying. So we could very easily get the timestamps of the exact moments that cows either rise or lie down. So this massively helped, of course, the analysis, because now we knew exactly the moments cows were rising and lying down. And then we also, from these timestamps, could calculate the lying duration, the lying frequency, and also the mean lying bout duration. So that's all done already in this R package. And then using these timestamps of the rising and lying down events, we used video recordings of the barn to then assess these rising and lying down events according to this ethogram. You can already see, for example, horse-like rising is in there. But we focus now in this presentation, especially on behaviors related to the head lunge. So we assessed whether the head lunge was staggered or fluent. And then we also said whether the movement was sideways or it was straight. And then after the head lunge, we assessed whether the cows needed to crawl backwards while resting on the carpal joints. So that's this extra step to the back after the head lunge has been performed. And during lying down, for this presentation, we will focus on the behaviors during the inspection phase. So that is, the cow inspect more than 2 times with the head the bedding surface. Also, did she step into the same place with the front legs more than 2 times? And did she paw away the bedding material right before the lying down movement? And in this study, we also looked at the defecation behavior of the cow, and specifically the defecation behavior right before or right after the rising event, so within 1 minute. And then we assessed whether she defecated within this time window, also where the majority of the feces landed, so either in the cubicle or in the walking alley. And then lastly, the posture of the cow at the start of the defecation, so either with all the 4 hooves in the cubicle, or standing with only the front hooves in the cubicle, or still lying in the cubicle. And then for the statistical analysis, we used generalized linear mixed models. And this was the model formula where we had this response, so either the NSH ratio or the NSD ratio as a fixed effect. And then we had the cow nested within pen as random effect as well as weak. And we assessed the statistical significance using odds ratios and 95% confidence interval using parametric bootstrapping. And to relate this back to like classic statistics, we considered a difference significant if the odds ratio of this confidence interval does not include 1. Because an odds ratio of 1, it would mean that the odds stay the same, basically. So then we come to the results of the neck strap positioning. Here first we have the different behaviors we assess during rising. So it's staggered head lunging, sideways head lunging, and crawling backwards. Blue is the model estimate with the 95% confidence interval of the fixed effect. And then the points are the individual observed proportions for the cows, just to give you an idea. So every cow has 3 points in this case because we tested 3 different heights. And then on the x-axis, we have the NSH ratio, which was the neck strap height divided by the wither height. And on the y-axis, we have the probability of this behavior occurring. And then in plot B, we have the odds ratio for a 0.1 increase in NSH ratio. So for example, going from 0.7 to 0.8, how do the odds change then of this behavior? And first, we see that in general, staggered head lunging, the probability was very low. And we also see no effect of NSH ratio on this behavior. That's maybe not so surprising because the neck strap is above the cow, so it would probably not interfere with the head lunge movement that she makes. But still, it's good to see that we saw a low probability of this. And then sideways head lunging, it was a little bit more common, but we saw no real effect of NSH ratio on this behavior. And the sideways head lunging, it has more to do probably with the amount of lunge space that she has in front of her, which was in our research barn 80 centimeters, which we know is probably not enough for the cow to make a straight head lunge. And then lastly, on crawling backwards, so that's this behavior that the cow makes while on the carpal joints, stepping back. We saw that in general, that the probability was already quite low, so that's good. But still, increasing the NSH ratio by 0.1, it decreased the odds of this behavior. So to completely avoid this behavior, maybe the NSH ratio should be a little bit higher than 0.7 in this case. And just to show you that video again, this is where the neck strap was at 105 centimeters, which we can see maybe especially for the bigger cows, this is still a little bit too low as the cow had to crawl backwards on her carpal joints. And we have, however, also the other side is where we see when the neck strap is positioned a little bit higher. In this case, it was the intermediate position, 120 centimeters. It allows the cows to walk into the cubicle a little bit further and lie down more in the front. And then, especially in the wall-facing cubicles, the effective space then remaining for the head lunge is smaller. And then in the end, the cow has issues with rising, as you can see here. So the neck strap is also really there to guide the cows also for themselves, that they have still enough space to rise without too much difficulties. Then we come to the lying down behaviors. And we have extensive inspection, so more than 2 of these head pendulum movements, repeated stepping in place and pawing. There we see a similar pattern that all these 3 behaviors were not very common, and that also there was no effect of neck strap height on their probability. So in this case, the height of the neck strap doesn't really seem to affect the hesitancy of the cows before lying down. Then we come to the defecation behavior of the cows. So as said, we assess the defecations, especially around rising events. And now here on the y-axis, we have the probability that the feces lands in the cubicle when a cow defecates. And there we can see a stark increase of this probability. So moving from 0.7 to 0.8, it more than doubles the probability that feces land in the cubicle when a cow defecates. And we also analyze that in more detail because we have the posture of the cow. So we can see that that is both the case for cows that defecate while lying, but also for cows that are already standing. So increasing the relative space, the relative height, it both allows cows to lie further forward in the cubicle and also stand further forward in the cubicle. Then we come to the NSD ratio. So this is the next strap distance from the curb divided by the cow body length. And there we see a very similar pattern as for next strap height, in the sense that staggered head lunging probability was always low without an effect of NSD ratio. Sideways head lunging was more common, but also no effect of the positioning there. And crawling backwards, in this case, it was very low. And here we did not see an effect of next strap positioning. On the lying down behaviors, I can also be very quick. Again, there we saw generally low prevalence and no effect of the neck strap distance from the curb relative to the diagonal body length. But also here for the defecation behavior, we did see an increase. So also moving the neck strap further from the curb relative to the cow body size, it increases the probability of defecation landing inside the cubicle by almost 2 times. And here we saw this mainly for lying cows, and we didn't see this for cows that were already standing. This could indicate that the cows were only lying further forward in the cubicle and not really standing, or it could just be that we did not have enough statistical power to detect this effect, because as you can see, the number of cases was quite low, which we had to do the statistical analysis with. Okay, so that was the study on neck strap positioning. Then we come to the second study, where we looked at the design of lying cubicles on commercial farms here in Switzerland. And there we had 2 types of lying cubicles. On the one hand, we had this cubicle on the left and this cubicle on the right. The cubicle on the left, he had partitions with open sides, which we think allows maybe the cow to use. We called it the restrictive cubicle. And then we had 4 farms with this permissive cubicle type, and then 6 farms with the restrictive cubicle. And all the farms that we selected, they had only wall-facing cubicles, and all of them had only 60 to 70 centimeters lunge space, for which we know that's not enough for a forward head lunge. And then on each farm, we selected 20 cows, and we had a similar methodology as the neck strap study. So we again attached these accelerometers that gave us the exact time points of rising and lying down, as well as the general lying behavior. We just did not record the defecation behavior in this study. And we used generalized linear mixed models, where in this case, as a fixed effect, we had this categorical cubicle type, so either restrictive or permissive. Again, cow nested within the farm, this case, as a random effect, and we also included breed here. And we again assessed the statistical significance using contrast, so calculate the difference between the 2 categories, and then analyze the confidence interval. And for this study, a significant difference was when the contrast didn't include 0, because if the difference includes 0, then there basically is not a statistical difference. Okay, then we come to the results of that study. So just to remind you, we had these 2 cubicles, the restrictive and the permissive type. And now in each panel here, we have a different atypical rising behavior, starting with staggered head lunging. And then in orange, we have the observed proportions and the model estimate. And in blue here, those for the permissive cubicle type. So for staggered head lunging, we saw quite a clear difference in the sense that they often had problems with head lunging in this restrictive cubicle type. Also looking at the contrast estimate here, we can see that the confidence interval does not overlap with 0. And then looking at the second plot, sideways head lunging, we see that in both cubicle types, the probability was basically 1. So combining these 2 plots, it confirmed our hypothesis that in these cubicles with a small lunge base, they always have to make a sideways head lunge. But then with a more open type of partition, they have in this study, we did not see an effect of a neck rail versus a neck strap in this case. And then also on the lying down events here, we saw differences, especially for extensive inspection and repeated stepping, where we saw that these are performed more often in a restrictive cubicle type compared to a permissive cubicle type. The confidence intervals, they overlap a little bit with 0 maybe. So we consider the statistical effect not very strong, but still it's an indication for us that maybe the cows are a little bit more hesitant to lie down in this restrictive cubicle type. Perhaps because they have like previous bad experiences with rising, and they know, okay, I will have trouble again standing up here, or something else. We don't really know, but that could be the case. And then lastly, on pawing the bedding material, we saw no effect of cubicle type. And then we come to the general lying behavior in this case, which was really quite interesting. There we saw productive. And we also saw this difference in lying frequency. So here we saw a difference of almost 2 lying bouts per day more in the permissive cubicle type. So again, this would align with the idea that when the cow can rise easily and is not hesitant to lie down, she also does it more often. This was, of course, only a small sample, and it would be really interesting to study this effect further because, yeah, it's relevant both to the cows, but also to the farmers. So then we come to the main conclusions of my thesis. Firstly, we see that the positioning of a flexible neck strap, it does not really affect the rising and lying down movements that much, but it does really strongly affect cubicle soiling. So that's something to balance. Then we also see that open partitions, they are associated with more fluent head lunging, especially in cubicles where there is not a lot of forward lunging space. And then lastly, we see that if the rising and lying down are impeded, this may also reduce the lying frequency and the duration of the cows. And then we come to the take-home messages. It's first that flexible neck straps, we see that they are effective in limiting soiling of the bedding without considerably hindering the rising and lying down behaviors. And this could be relevant because especially rigid neck rails in the literature, they are considered as quite problematic. There are records of cows hitting the rails and getting injured or even fractures. So the flexible neck strap, it appears to be a viable alternative there. And then also we see that both the open partitions as well as the flexible neck strap, they enable farmers to make welfare improvements in current barn buildings without changing the cubicle dimensions. Because often it's not economically feasible for a farmer to completely demolish his barn and build a new one, a bigger one, because the barn, yeah, it's made to last around 20 to 30 years here in Switzerland. But replacing these specific cubicle hardware elements can already make quite big improvements, we think, to dairy cow welfare. So that's hopefully a good thing. Okay, so then I already thank you for your attention. Of course, welcome to any questions if you have them.
Thank you, Stijn, for a beautiful and clear presentation. While we wait for people to type questions into the chat box, I have 1 or 2 questions to get us started, if that's okay.
Yeah.
The first, so cubicle housing it's an efficient way to keep animals clean, but it might cause discomfort. So when they're hitting their neck while standing. And any change to allow for more what we perceive as comfort. So in your study, making the neck rail flexible and perhaps higher, it creates in some ways more work for farmers, and also it might be challenging for animals' health because it's a dirtier pen. Is cubicle housing just a constraining system that we must use? Or do you think after a few years of studying it that we could just rethink how cows are housed?
Yeah, that's a reoccurring question during my PhD. And I think to a certain degree, the cubicle housing system will always be a compromise because in order to limit the defecation behavior inside the cubicles, inherently other behaviors will also be restricted. So in that sense, I do think it will always be a compromise. And maybe for the long run, we should look more into more open systems like deep bedded packs. However, the positive things from at least my PhD were that we can, in certain aspects, improve one thing without coming at the cost of the other. So, for example, I believe that just having a flexible strap over a rigid rail already makes an improvement to the cow comfort without coming at the cost of hygiene.
Great, thank you. Katerina types, hello, thank you for the presentation. It is a very useful study. I'm wondering if you also assess the incidence or severity of lesions, for example, hawk lesions. I feel it would nicely complement your research. Thanks.
Yeah, it would have been interesting. Unfortunately, we did not do that. On the farms, it was just not feasible. And luckily, on our research farms, also by talking to the farm staff, we knew that there were not so many injuries. So yeah, luckily the housing system was already relatively good. But yeah, it would definitely be interesting to look at more at the injuries. I would really like to do a study with neck rails where we could directly compare the rails to the flexible straps, for example, and then also compare the injury rate. Yeah.
Great. There's a few complimentary texts in the box just saying congratulations. And while I see if there's another question, I have one more. You mentioned that the cows lie down more and for longer in the permissive cubicle type. You mentioned that might be because they learn it's not so difficult to rise and lie down, and they're more willing to pay that cost in a way. But do you think it could also be that they might be able to rest differently? Do you know if they can lie down laterally in the permissive type of cubicle?
Yeah, that's another thing. Indeed, the partition shape is different also at the back. So it has a bit more of a high back that we think also allows them to adopt different lying positions. So it's definitely multifactorial in that sense. We do think that the cows ideally would lie down around 1 hour and then change the lying position, for example, by interrupting this lying bout and starting a new one, because they are lying with a lot of weight on one side. So that's why we're always very interested in especially the lying frequency. And the lying duration is maybe a side effect, which is nice for the farmer. But what we based our conclusions on was mainly this lying frequency in this case. Yeah, but it is true. There are more factors affecting that for sure. Yeah.
Great, thank you. And yeah, one last one from me. So now you've spent maybe more time than you thought you ever would thinking about a neck rail and how it could be manipulated. What do you think would be next for how you would change the cubicle housing?
Okay, so yeah, if we stick with the cubicle housing, one thing that has to change, and luckily is already changing, is that we create cubicles with more forward space. So if the forward space is sufficient, then, for example, the cow, it doesn't even need to use the lateral space. So I think that would be the next step, to have that as the standard, just a larger forward space. And then, yeah, maybe look more at the natural behavior of the cow. So one thing we see on the pasture is when they rise, they are really motivated to then start walking forwards, because that's their natural behavior, and not walk backwards. But unfortunately, the cubicle, it always forces them to enter or to exit the cubicle also backwards. Now, there are also systems where the cows can enter and in the back and exit through the front. So maybe rethink the housing system more really in terms of the natural behavior of the cow. I think that would be the next step. Yeah.
Great. Thank you so much, Stijn, for, again, your presentation and your great answers to all of the questions. Congratulations on finishing your PhD, and
Yeah, thanks a
thank
lot.
you for tonight.
Yeah, my pleasure. Thank you.